So this part here, like I mentioned, is on 3D diagrams, 3D figures. So what happens here is that you need to try to visualize this object that they attempted to draw on 2D paper. This is actually a 3D object, what we call a triangular prism. Now, what is a triangular prism? A triangular prism is an object with triangle as the cross-sectional area. Okay, or the cross section is a triangle. And then when the word prism actually, let me highlight it in another color. The word prism actually means that along the entire length, no matter how you so-called cut it, you will get back the same triangle. So for example, if I choose to say, chop this object at this red color line here, what happens is that you will end up with the exact same triangle as the cross section. Okay, so this is, just a recap of what a prism is. Now, all the dotted lines are at the back that you are not supposed to be able to see. However, the question also labeled this line as a dotted line, but this line actually is on a surface that you can see. AF is actually the sloping surface which is facing you in that sense. Okay, but whatever it is, try to be able to visualize this object. Okay, so what happens here is that in this object, right, they will tell you certain information and then you will have to use Trigo to try to solve it, to try to find some certain things. Okay, so what are some of the things? So for example, in this question, they want you to find AC. Okay, so what happens here is that if they want you to find AC, again, ask yourself, AC, what is it part of? Okay, every single time you do a Trigo question, when they ask you to find a length, you ask yourself, what is it part of? Is it part of any triangle, for example? Okay, and yes, it's part of this triangle, which I drew just now, and this is a right angle triangle. So the thinking process is very important. This is a right angle triangle. Don't even think of don't even think of sine rule and cosine rule. Think of your Torcaso and Pythagoras theorem. Okay, so this question, you don't know any of the acute angles inside, but you know two sides. You want to find the hypotenuse. So AC is very clear cut. Just use Pythagoras theorem, you can find AC. Okay, now what about AF? So like AF over here that I mentioned, this one over here is the diagonal along the sloping surface, the sloping rectangle ACFD. Okay, so first and foremost, you need to recognize that it is part of this sloping rectangle over here. Okay, and this is a rectangle. So if this is a rectangle, this is a right angle, and hence AF is part of another right angle triangle. In particular, AF is part of, let me highlight in green for you, this right angle triangle. Okay, you would have found AC by then. You have this length to be 8. So you can find AF again using your Pythagoras theorem. Okay, so try to understand the thinking process behind this. And for now, I will just give you all some time to finish up the working for this question. Okay, having guided you all through the thinking process, and then we'll double check the answer. Okay, I don't think you all need too long, so maybe 1 minute will do. When you are done, let me know, okay? Okay, since you are done, actually the working is very short. Okay, so just Pythagoras theorem twice, but the important thing is to be able to visualize what is happening in this object, and then try your best to be able to do the question. Okay, now, so let's move on to the next one over here. Now, this question is an O-level question, which I actually adapted and added. Actually, no, I will add one more part later on. But at least for now, this is an O-level question, which a lot of people got one particular part wrong. I'm not going to tell you which part. Okay, but what happens here is I will give you all some time to try. Okay, but I will focus a lot more on part 1, part 3, and part 4. Okay, so part 2 is a surface area, which is actually part of mensuration. But y'all can do also. Okay, so all I want to ask you all to do is to try part 1 first. Okay, and part 2. Okay, once you are done with part 1 and part 2, let me know. Then you move on to part 3. Okay, but I want to go through focus on part 3 and 4. Okay, but try part 1 and part 2 first. Then I will go through with you all before you all try part 3. Okay, so for part A and part B, right? Part A wants you to show that the angle BAC is 58.4. So BAC is this angle over here. Okay, so again, every time you do a trigo question, got angle, got triangle, right? Okay, ask yourself what triangle is this angle part of? Okay, so this is the only triangle that this angle is part of. Ask yourself what you have in this triangle. So this triangle, you have 3 sides and you want to find the one angle. So 3 sides, 1 angle, you think of cosine rule. Okay, so for cosine rule, when you apply, just make sure that the side opposite the angle, they are opposite each other in the cosine rule. Okay, and then after that, you just need to remember how to rearrange to find the angle BAC, and you will see that it's 58.4 degrees. Okay, now even if you don't know how to do part A, please understand that this is the answer for part A. So they literally gave you the answer, so you can take the answer and continue and do the subsequent parts if you need. Okay, then the next one is your surface area. Now, this is a prism. Okay, so for a prism, right, the surface area is going to be the 2 triangles. So the triangle in front and the triangle behind, you add them together, and then you will need to add all the other sides, right? So there are actually 3 sides here. This one facing you, this one at the back, and the one at the bottom. So all 3 sides can be found with one working, and I hope you all know how to do so. Okay, so your set 2 teacher should have went through this with you. For the sides, right, what you need to do is to find what is the perimeter of this triangle, which is very easy because 3 plus 6 plus 7 gives you the perimeter. Okay, and what you do is you multiply the perimeter by 10. So when you multiply the perimeter by 10, right, you are in a way a little bit like scanning through this entire length. And then you realize that you scan through this, you are actually finding all the sides added together. Alternatively, what you can picture is that you imagine this is like a cardboard thingy, and then you cut along this blue line, you open up, you will see that you open up, you become a rectangle. Or your school teachers might have done this with you take a toilet roll, you cut it. The curved surface area of the toilet roll, right, is actually when you cut it, you open up, it's actually a rectangle. So this is the same idea here. You find the perimeter, you multiply by the entire 10, the length, you will get the surface area. Okay, so the surface area, you take the 2 triangles, add together. Now triangles, that's where they are testing you half AB sine C. So you use half AB sine C, then you times 2. Okay, then this one, like I mentioned, is the perimeter times the length. So one shot, you get the total surface area to be 178 cm square, 3SF. Okay, so I go through part C first, okay? So for part C, the vertical distance of C above AB. Okay, so what you want is actually this line over here. Imagine with me that it is perpendicular to AB. Okay, so your aim is to find what is the length of this line over here. That is what we mean by vertical distance of C above AB. AB, imagine it as it is actually on the ground, okay, on the flat surface ground. Okay, so the vertical distance, how do you do it? Now, actually, you have already found angle BAC. Huh? So what happens here is try to understand. First and foremost is that this line and this line, they must be perpendicular to each other. That's why it's called vertical distance. Second thing is, once you know it's a right angle, this is a right angle triangle, of which you know what is angle BAC. Okay, so since you know what is angle BAC, you can use your Tuakaso. Again, use Tuakaso because this is a right angle triangle. So don't think about sine rule, cosine rule, for example. Okay, so use your tokasu to find the distance. In this case, I call it x. So you should be able to get 2.5555 or 2.563SF. Okay, so for this question over here, right, a lot of people, when they do this question, right, when they want to find the angle of elevation of E from A, okay, E is actually this point over here. A is actually this point over here. So a lot of people can identify that, oh, this line will be when you look up from A to E lah. Okay, now the number one mistake that a lot of people make, right, is actually thinking that this line over here, which forms this angle over here, is the angle of elevation. So a lot of people made these mistakes, and I need you to know why this is a mistake in the first place. Okay, because number one, the angle of elevation of something, right? When you're standing at A, you must look straight ahead in front of you, yes, correct. But you must look straight ahead in front of you, but directly underneath E. Okay, so it doesn't make sense for you to not look directly underneath E. So for example, if you want to look up at your friend, it's when you look directly in front of you underneath your friend, then you look up. That's the angle of elevation. You don't look at somewhere else, then you tilt your head diagonally upwards. And then you call that the angle of elevation. That is not the angle of elevation. So if you did it this way, you are actually looking at whatever this point is, and then you tilt your head diagonally upwards, which is not the angle of elevation. So where is the angle of elevation here? The angle of elevation requires you to, number one, drop a vertical line down from E to this line over here at the bottom. And then this is the line that so-called looks straight ahead, and you tilt your head upwards. So this is the angle of elevation, and it is different from the previous one that I mentioned, which a lot of people got wrong for. To find this angle of elevation, you need to realize that the triangle that I drew here is actually a right angle triangle. Okay, first and foremost. And you have actually found this height here in the previous part. Previous part, you found this, right? 2.5555. And this line over here is actually the same length, 2.5555. So actually you have this length over here, and you want to find this angle of elevation, which I'm going to call it theta. So what happens here is you must realize that it is a right angle triangle, and hence you just need to find one more length anywhere. Meaning you can find this one that I'm going to highlight in green here, which is the hypotenuse. Or you can find this one over here, which is your adjacent. Up to you. Okay, the easier to find one is this line over here, which I believe a lot of you would have found. How do I find this line over here? Try to picture the back rectangle over here that I highlighted in green. That line AE is actually the diagonal of this rectangle. Okay, so if I draw it out for you, or rather, let me just draw it separately here. This rectangle at the back, let me call it A, C, E is here. This one I don't know what is it, but it doesn't matter. Your aim is to find AE. Okay, and actually, you know that this is 3 and this is 10, which means that in this rectangle, you can find what is AE using Pythagoras theorem. And once you have AE, this is AE, okay, you can use your tokasu to find you can use your tokasu to find what is the angle of elevation. Okay, so you should be able to get 14.2 as the answer. Okay, so for B part 1, right? For B part 1, what happens here is that you want to find what is AM, okay? And try to understand that the flagpole is at CM and it is vertically upright, which means that this triangle here is actually a right angle triangle. So you use Pythagoras theorem to find AM. In a very similar way, they gave you BM in part 2 to be 6.95. And this is again a right angle triangle. So you can find the angle of elevation here. Okay, and the very last one is trying to ask you to find A angle AMB. AMB is this angle over here, which is part of this triangle. Okay, so you have this triangle, you have 3 sides, and this is the angle you are trying to find. So you use cosine rule to find angle AMB. Okay, so I'll just briefly show you all the answer, but try, okay, including part A as well, then try to be able to do the question.